So the topic of our video assignment is properties of DTFT and the properties of DTFS. So here we go. First I will discuss the properties of DTFT. So properties of DTFT. Discrete time Fourier transform. First properties is linearity property. Second is time shift. Third is frequency shift. Fourth is scaling property. Fifth is differentiation in frequency domain. Sixth is time reversal. Seventh, convolution. And eighth is Parseval theorem. So all the properties of DTFT and CTFT are almost similar. The only difference is in the analysis equation of CTFT and DTFT. In CTFT we have x of j omega is equals to integration minus infinity to infinity x of t e to the power minus j omega t dt. That's an analysis equation. And in DTFT we have x of e j omega is equals to summation and is equals to minus infinity to infinity x of n e raised to power minus j and omega. Difference is in this j omega and this is replaced by here by e raised to power j omega, and in this t is replaced by n and integration is replaced by summation. So first property is linearity property. So we know that x of n forms DTFT pair with x of e j omega and yn forms DTFT pair with y of e j omega. So x of n DTFT x of e j omega So the property of linearity says that if input is weighted sum of one or more signals, then the output is weighted sum of responses of two individual signals. That means z of n is equals to a x of n plus b y of n. So DTFT is that's an output j e j omega. So it says that input is weighted sum of one or more signals, then the output is weighted sum of responses of two individual signals. Proof. So we know that j of e j omega is minus infinity to infinity z of n e j omega n, and z of n is here a x of n plus b y of n. So A x of n plus B y of n e minus j omega n. So by solving this, this is nothing but x of e j omega, and this is nothing but x of y j omega. So by solving, we get z of e j omega is nothing but a of x e j omega plus b of y e j omega. So that's seniority property. So the second property is time shift property. So we know that x of n forms DTFT pair with x of e j omega. So the time shift property states that if x of n minus n naught is equals to e to power minus j omega n naught, e to power j omega equals to j, a shift in the input will be will given the results e to the power minus j omega naught into e to the power j omega. Proof. So we know that z of e j omega is equals to summation as for n is to minus infinity to infinity z of n e to the power minus j omega n equals to n is equals to minus infinity to infinity x of we replace n to n minus n naught e to the power minus j omega n naught. Here we replace n minus n naught to m. So by replacing n minus n naught to m, we get x of m e to the power minus j omega n. Okay, so and here n is replaced by n is equals to m plus n naught. So by replacing n to m plus n naught, by separating these term, so the summation is with m, okay, and here is n naught, so this behaves as a constant for that. So by equating this equation we get so this is nothing but x of e j omega hence proof. So it says basically that if there is a shift in the input, then there will be exponential multiplied by that shift version in output. So the third properties is frequency shift. So we know x of n, so DTFT pair with x of e j omega. Then e of j omega not n x of n DTFT is x of e j omega minus omega naught. That's an input. Let z, this is z of n, and let this is z of e j omega. Proof. So proof. So we know z of e j omega is summation n is equals to n minus infinity to infinity z of n e raised to power minus j omega n. Okay, so z of n is here we let z of n is e j omega n x of n. So by replacing z of n with e raised to power j omega n naught x of n, here we get minus infinity to infinity e to power z omega naught n x of n e to power minus j omega n. By taking j common in this, j omega minus omega naught n. Okay. So we know that x of e j omega is n equals to minus infinity to infinity x of n e to power minus j omega n, and z of e j omega is x e z omega minus omega naught. So that means x of e j omega is correspond to this omega, okay, present here, means ye this omega correspond to this omega present there. So it is opposite to the time shift. If we have a shift in the time, there will be exponential multiplier with the negative sign in the output, and if we have multiplier or exponential in the input, output will be frequency shift in the output. So that becomes z of e j omega x e j omega minus omega naught. Fourth property is scaling property. So we know x of n forms DTFT pair with x of e j omega, and z of n then z of n is equals to x of np DTFT. Z of e z omega is x of e j omega over p. It says that if x of n forms DTFT pair with x of e j omega, then x of np is equals to z x of e j omega over p. Proof. So from the basics we know z of e j omega is equals to n is equals to minus infinity to infinity z of n is power minus j omega n, and z of n is x of np. So by replacing x of np there, we get n is equals to minus infinity to infinity x of np e raised to power minus j omega n. So we substitute np with other variable m. By substituting np with other variable m, we get minus j omega, and there n, here we get n is equals to m over p. So m over p. So by rearranging the terms, we get e to power minus j omega over p m. So that becomes z of e j omega is equals to x of e j omega over p. This comes from, we know that x of e j omega is equals to n is equals to minus infinity to infinity x of n is to power minus j omega n. So if omega is replaced by omega over p, then we get that. So hence proved property 4th. Property 5. Fifth property is differentiation in frequency domain. So we know x of n forms DTFT pair with x of e j omega, then minus j and x of n DTFT with differentiation with respect to omega x of e j omega. Proof. So we know x of e j omega is summation and it's equals to minus infinity to infinity x of n e to power minus j omega n. So differentiating this with respect to omega, we get d by d omega x of e j omega is equals to differentiating both sides with respect to omega. So this is n. Okay, so we differentiate only that, minus infinity to infinity x of n So the differentiation of e minus j omega n is e minus j omega n, and differentiating again with this we get minus j n. Rearranging the terms, we get minus j n x of n e raised to power minus j omega n. So we know x of e j omega already is summation as equals to minus infinity to infinity x of n e to power minus j omega n. So we write x of n forms DTFT pair with x of e j omega. In this, if in place of x of n we have minus j n x of n, then this will form Fourier transform function with the function minus j n x of n. Okay, DTFT x of e j omega, hence proof. Now we study the properties of discrete Fourier series. Properties of discrete Fourier series. Through this we assume two periodic signal, that is x of n and y of n with a period n, and with the Fourier coefficient c of k and d of k respectively. So discrete Fourier series x of n, coefficient is c of k, okay, or we can say x of n forms discrete Fourier series pair with c of k. First property is linearity property. It states that if x of n and y of n are two sequences are two sequences with period n with period n and with Fourier series coefficient C of k and D of k, then a1 of x a1 x1 n plus a2 x2 n is equals to a1 ck plus a2 dk, where a1 and a2 are the constants. That's a linear property. Second property is time shifting. It states that if DFS x of n is equals to ck, then discrete Fourier series of x of n minus n naught is equals to c of k e raised to power minus jk 2 pi by n over into n naught. So that's in time shift. It says that if there is a shift in if we shift that by n naught, then there is an exponential term there. So third is conjugation. It states that if discrete Fourier series of x of n is c of k, then discrete Fourier series of x conjugate n is equals to conjugate of c of minus k. That's in conjugation property. Now fourth property is time reversal property. It states that if discrete Fourier series of x of n is equals to c of k, then discrete Fourier series of x of minus n is equals to c of minus k. Time reversal property. Fifth is periodic convolution. It states that if x of n and y of n are two periodic sequences, with period n and with Fourier series coefficient ck and dk, then Fourier series of periodic convolution of x of n and y of n is discrete Fourier series summation x of r y n minus r equals to n c of k and d of k. So that's an periodic convolution. So we have only to prove 5 properties. So here we go. That's it. Thank you.